Welcome! This is a demonstration of the AI inferencing on IBM Power 10, showcasing its Matrix Math Accelerator, or MMA, capability. AI is infused in many industries from banking to manufacturing supply chain. We will show you some examples of these real-world scenarios on how AI can be part of the solution on Power 10. We'll focus on AI inferencing, where the models can be trained anywhere and inferencing is done on Power 10. These demos were made by the IBM Systems Technology Innovation and Incubation team. Imagine you're a data scientist or a developer. You may wonder how to do AI inferencing on the latest IBM Power 10 server. Well, it's actually quite straightforward. With a container-based approach, it is easy to set up a virtual Python environment typically required for data science work. First, we create a basic Python virtual environment with Anaconda machine learning platform. Then we install the necessary AI packages from a specific Conda channel named Rocket CE that include the libraries already optimized for the Matrix Math Accelerator on Power 10. Libraries that are optimized so that AI applications running Python using PyTorch and TensorFlow can take advantage of MMA. Our demos are built using a demo framework that consists of a set of containers and microservices. The stacked containers offer flexibility in choosing AI frameworks and allows the inferencing applications to run on multiple architectures and hosting environments. In this case, we start with a common base image, followed by adding the AI base layer, which consists of setting up Anaconda and creating a project space. The AI framework layer installs specific AI libraries and dependencies, setting up the required environment for inferencing. To illustrate the performance advantage of MMA, we include a set of generic AI frameworks, as well as the optimized set, to compare the difference. The demo UI architecture is also built using a modular approach. Common sections include application description, system resources, and performance results. The demo framework is designed for the ease of adding new applications. The UI can automatically detect which applications are available and enable only those that are runnable. For example, as a new runtime is added, such as Onyx runtime, it becomes available in the AI runtime settings selection. Each application consists of an inference server, APIs for communicating with the demo UI, utilities to query the system resources and runtime resource utilization, including number of vCPUs, available memory, and peak runtime memory. The AI runtime settings area is customized based on the supported or implemented AI frameworks for comparison of performance on using different frameworks with and without the libraries optimized for MMA. This allows us to add more frameworks as they are implemented. All the images used are also saved and served from our internal registry, so the entire demo suite can be active using a simple all-in-one install script. And now let's dive into the 6 demos. This real-time object detection use case is currently being used by IBM Supply Chain for quality inspection. This is an example of the Z-frames inspection. It is a multi-stage inspection process using YOLO 3 AI models trained on the IBM Maximo Visual Inspection platform. The first stage identifies the different components that are present in a Z-frame. The resulting bounding box is then passed to a second stage, which then counts the number of screws it finds in the bounding box, signaling if any screws are missing when compared to the known configuration. The screw counter is more precise and at least 10 times faster than a human. Here we'll demonstrate the screw counter using PyTorch and Onyx runtime. You see that using the MMA enhanced libraries show 2 to 3 times speed up compared to no MMA, where Onyx runtime is especially faster. This is a video action recognition scenario, which has applications in many areas, including security and safety monitoring. This Adaptive Resolution Network, or ARNet model, was developed and refined by IBM Research. With this demo, we show how we can quickly turn a research asset into a demo on Power 10. ARNet consists of a policy network and different backbone networks corresponding to different resolutions. The policy network decides what resolutions to use or skip on a per-frame basis to achieve accuracy and efficiency. During inference, input frames are first fed into the policy network to decide the proper resolutions. Then the rescaled frames are routed to corresponding backbones to generate predictions. Finally, the network averages all the predictions for action classification. This model was trained on the internal GPU cluster on IBM Cloud. As such, this is another example of train anywhere, run everywhere. This is a credit card fraud detection demo. As the cost of a data breach in financial services increases year over year, it is highly desirable to use AI to identify fraud in a secure, low latency, and high throughput fashion. The intent here is to use AI in line with transaction or directly within the database where the data resides. For example, credit card transaction data are kept in the database tables in IBM DB2, and the inferencing is done as part of the SQL query via user-defined functions. For this demo, however, we are running the data, model, and inferencing standalone outside of DB2 to showcase the inferencing power of MMA. Even though the runtime comparisons are comparable, in fact, 90% of the time is spent in pre-processing of the data in this particular case. The actual prediction time using the MMA optimized libraries do provide a 1 to 2x speed improvement. This is a speech-to-text demo that uses automatic speech recognition built on the public Hugging Face model. There are many applications for transcribing audio to text. For example, a hospital in Southeast Asia currently uses a traditional pathology system that is inefficient, lacks data linkage and integration, and has long patient response times of 2 to 4 weeks. As part of their overall digital pathology solution, using speech-to-text, they can instantly transcribe patient information and have the data and results available online. This is another example of using the LSTM machine learning model for time series forecasting. The two sample datasets used in this demo are the Air Canada stock price in Q4 of 2018 and the Consumer Price Index from the Federal Reserve Economic Data, which is an indicator for inflation. Again, in this example, most of the inferencing time, or 90% of the time, is spent in pre-processing of the data. This is a demo of the CERN neutrino interaction denoising application. To further demonstrate Power 10 compute capability, a large memory model is used to show that inferencing is faster with no need of splitting the input images into smaller sizes. A prototype single-phase detector has been built for the CERN neutrino platform to perform experiments in the neutrino oscillation research field. The platform measures particle interactions in liquid argon, which produce ionization electrons that are drifted towards 6 anode plane assemblies, each with 960 wires in its collection plane. The raw measurements are cast into a 6000 by 960 resolution image, plotting an analog to digital converter values heat map over time versus the wire number. This application tackles the denoising of these images, which are sparse and large, requiring careful memory management while dealing with complex model architectures. This example shows taking 1/4 row of the neutrino interaction image and finding where the interaction or lines occur. As shown, using PyTorch with MMA is faster and uses slightly less memory. With Power 10 and MMA on-chip acceleration, AI inferencing becomes part of the workload and data processing right on the system embedded in the path of application execution. Although our results are not meant for benchmarking, we have demonstrated the speed up with MMA and the benefit of using Power 10 MMA for AI inferencing. Thank you.